Okay, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, this is the video to explain about the tasks or question that I have given to you. Okay. Okay, the question is to sketch the graph of fx equal to 4x minus 5 over x square minus 1 by using the derivative method. Okay, so when we are given with this equation, then to sketch it by using the derivative method, first of all is to do the first order derivative. Okay, since this is a fraction, so we need to use the quotient rule, so which is x square minus 1 and 4 minus 4x minus 5 and 2x over x square minus 1 square. Okay, so then we have here is 4x square minus 4 minus 8x square plus 10x over x square minus 1 square. So then we have negative 4x square plus 10x minus 4 over x square minus 1 square. So first is to find the stationary point or the critical point. Is we equal this first order derivative to 0. So then we have negative 4x square plus 10x minus 4 equal to 0. And we factorize this, then we have 2x minus 1 and x minus 2 equal to 0. So then we have here is x equal to 1 over 2 and x equal to 2. So this is where the critical point will happen. Critical point, but it's actually not a point yet because we didn't have the position for y axis, but never mind. We find the y axis by substituting the value of x into the original equation, f 1 over 2. Okay, so when we have x equal to 1 over 2, so then we have here the answer is 4, and when we have f, we substitute with value of 2, so then we have a value of 1. So the critical point is at 1 over 2, 4 and 2, 1. So this is the critical point. Okay, so next, since this is this equation given fx is a type of fraction, so we look at the denominator of x square minus 1, and the denominator cannot be equal to 0, so then x cannot be equal to positive and negative 1. So this will be the asymptote of the graph. So now we try to draw the line of the x-axis. So means here we have asymptote at negative 1. So this is the asymptote. So then we have the origin, which is 0 at the origin, and then we have line 1 over 2, and then we have asymptote of positive 1. This is the asymptote, and then we have another point at point 2. So means we have a region that region of interval is this area, So we have 1, 2, 3, 4, and 5 intervals. So then we create the table to find the type of graph for each interval. So since we have 5 interval, so we need to provide 5 column for the interval 1, 2, 3, 4, and 5. So this is the interval test value and sign of f prime x. Okay, so our first interval is from negative infinity until negative 1, and then from negative 1 until 1 over 2, 1 over 2, and from 1 over 2 until 1, and 1 over 1 from 1 until 2, and then from 2 until positive infinity. So then we can choose any number within this interval as the test value, which is negative 2, 0, 2 over 3, 3 over 2, and 3. So then we can substitute this test value into our first order derivative, our dy dx. So we can find f prime negative 2, f prime 0, f prime 2 over 3, f prime 3 over 2, and f prime 3. Okay. The answer given is that we want to focus on the sign of the final answer. Here we get here is negative and negative, a positive, and a negative. So here is negative, negative, positive, positive, and negative. So the place within the same sign, the position that is within the same sign is negative and negative. So here is negative and negative, means here occurs point of inflection. But since negative 1 is a position of our asymptote, so here is asymptote, so this is not a point of inflection because of that line is a position of asymptote, and here is also an asymptote. Remember, our asymptote is at x equal to negative 1 and at x equal to 1. So here is the asymptote, and then we can say that here is negative and positive. So when the sign is changing from negative to positive, it is this type of this type of curve, and sign changing from positive to negative is this type of curve. So then we determine the y-intercept. So to determine the y-intercept, we take the original equation, we substitute with the value 0. So then we have 4, 0 minus 5 over 0 square minus 1. So then we have 5. So 5 is our y-intercept. So from here, this equation, we didn't need to do the second order derivative to find the point of inflection, because we already know the point of inflection actually should occur between of the same sign. but since in between of the same sign is an asymptote, so there is no point of inflection. Okay, then we have to find the y-intercept. The x-intercept. So the x-intercept is to take the original equation 4x minus 5 over x squared minus 1 equal to 0. So then we have 4x minus 5 equal to 0. So x equal to 5 over 4. So 5 over 4 is about 1.25. So this is our x-intercept. Okay, then we have to determine the horizontal asymptote. So in order to determine the horizontal asymptote, we need to apply the concept of limit, where x is approaching positive and negative infinity for function fx. So it will become limit x approaching positive negative infinity of 4x minus 5 over x squared minus 1. Okay, so to determine this, we have to use limit x approaching positive negative infinity is 4x over x squared minus 5 over x squared over x squared over x squared minus 1 over x squared. So then we have here is 4 over x minus 5 over x squared over 1 minus 1 over x squared. So then we substitute our limit. So then we have 4 over infinity minus 5 over infinity over 1 minus 1 over infinity. So then we have here 0 minus 0 over 1, which is equal to 0. So then our horizontal asymptote is y equal to 0. Okay, so then since we already have all of the information that we need, we can sketch the graph. So this is y, x, our asymptote 1 over 2 and 2, and then we need to know about our y-intercept is probably right here, and then our x-intercept, which is 1.25. Our x-intercept is right over here, 5 over for 1.25, 5 over 4. This is our x-intercept. So first we draw our line of vertical asymptote. Okay, so the region that we found for negative infinity until negative is a negative gradient. So since this is a asymptote, so the graph akan jadi like this lah, because right here have a negative gradient, and for region negative 1 until 1.2 is a negative, but we have a relative minimum point right here at point 1 over 2, 4. 1 over 2, 4 is our point of relative minimum. So this is negative and this is a positive. And then next is the region within 1 over 2 until 1 over 2 until 1 is positive. Okay, we already done that. And next is the region from 1 until 2. Since we have x-intercept at 5 over 4, so then our graph will be like this, and it's moving towards the relative maximum at point 2, 1. This is our point of 2, 1 relative maximum, and the y-intercept is at 5, 4, going at 2, 1, sorry. Ui, salah lukis. Okay, so our horizontal asymptote is at equal to y equal to 0. Don't forget our horizontal asymptote is at y equal to 0. So that's why that graph is never going down again, but it's only intercept at 5 over 4. Okay, so that is how we sketch the graph for this equation. So thank you.